All right, we'll get back to the topic 7 notes. We're on problem 10. Problem 10 is really where the logarithmic stuff begins in chapter 5 for the 115 class. It says, consider the functions f of x equal 3 to the x and g of x equal log base 3 of x. Complete the table and then use the points to sketch the graphs of f and g. F of x and g of x are inverses of each other. Y equal 3 to the x is the inverse of y equal log base 3 of x. And whenever you have two functions that are inverses of each other on the same picture, they're always going to be symmetric about the line y equal x. So I'm going to also draw that to include, to show that these are symmetric about that line there. All right, so I'm going to first graph y equal 3 to the x. That's an exponential. X can be anything. So I've got some x values already set up for us. 3 to the negative second power, that'd be the same as 1 over 3 squared, or 1/9. Okay, so here's negative 2 1/9. If x is negative 1, 3 to the negative first is 1/3. So here's negative 1 1/3. If x is 0, anything to the 0 power is 1. So here's 0 1 on the graph. If x is 1, 3 to the first is 3. Here's 1 3 on the graph. And if x is 2, 3 squared is 9. So here's 2 9 on the graph. Okay, now any exponential is 1 to 1. Here's the graph of the exponential y equal 3 to the x. Of course, there's a horizontal asymptote on this graph. The curve is going to be heading outward towards the left, but it's never going to get to the x-axis. Any exponential is 1 to 1, and 1 to 1 just means that the inverse is a function. Okay, now if I calculate the inverse of y equal 3 to the x, I just simply switch x and y, and so I'll have x equal 3 to the y. Now x equal 3 to the y means that y equals log base 3 of x in logarithmic form. Okay, so that's the definition of a logarithm there. So if I want to graph y equal log base 3 of x, I'll have to graph the inverse function of y equal 3 to the x. Again, these are inverses of each other. So inverse just means I switch x and y. Well, on this graph here, I would just simply switch the coordinates. Let me do that now. Okay, here's negative 2 1/9. That's me at 1/9 negative 2. Negative 1 1/3. That'll be at 1/3 negative 1. 0 1 will be at 1 0. 1 3 will be at 3 1. And then 2 9 will be at 9 2. So then you're going to draw this curve passing through these points. The horizontal asymptote that was on the graph of the exponential is now going to become a vertical asymptote on the graph of the logarithm. And that's a feature of a logarithm. Okay, here be y equals log base 3 of x. Okay, a logarithmic curve will always have a vertical asymptote on the graph. Now, notice how these two curves are symmetric about y equal x. Okay, I've drawn that diagonal line y equal x to show that how we get the graph of the logarithmic curve is really we just start with y equal 3 to the x, and if we rotate that graph about the diagonal line, we'll have all the points land in the same spot there. Okay, now I mentioned that the most important thing when it comes to logarithms is knowing the definition of a logarithm. Okay, if you have y equals log base a of x, that means that x equals a to the y. Now that is the most important thing when it comes to logarithms. You can also read this right to left, and that'd be the, using the line right above there. Okay, so in problems 11 and 12, I'm just having us get some practice using that definition. We're going to convert this equation, which is an exponential form, to a logarithmic form. So right now we're in the form x equal a to the y. We need to rewrite this in the form y equal log base a of x. So it looks like x is 12. That's going to be the input in the logarithm. B is the power of 5, so that'd be my y value. 5 is the base, so it's going to be the base of the logarithm. B equal log base 5 of 12, that would be my equation now, rewritten into a logarithmic form. Problem 12, we have a logarithmic equation. We want to rewrite that into an exponential form. Okay, so we're in the form y equal log base a of x. we want to rewrite that in the form x equal a to the y. So x is t, that's going to be all alone on the exponential. 2 is the base of the logarithm, so it'll be the base on the exponential. 6 is my y value, so 6 is going to be the power of 2. Okay, now I don't have to simplify this or anything, or solve for b, or solve for t. They're just simply wanting us to rewrite one form into another form. Okay, problem 13 is where we're going to find some values of logarithms here. In these problems, we're using the definition of a logarithm. The properties of logarithms are also very useful when it comes to finding values of logarithms. And I'll talk about that on the next page, though. So if I want to find the value of log base 3 of 9, let me call that y and apply the definition. Of course, I got to find the actual number for y to get the answer here. Now, y equal log base a of x means that x equal a to the y. So in exponential form, 3 is the base. You're going to have 3 to the y equals 9 is the x value. So 3 to the y equal 9. Okay. When you solve an exponential, the plan is to try to get the same base. Well, I can do that here. 3 squared is 9, right? And so I've got base 3 on both sides. I can remove the 3's and set the powers equal, and I'll have y equal 2. So log base 3 of 9, that's equal to 2. Here's another one, part B. Okay, begin by calling this y, and then apply the definition. So in exponential form, 1/16 is my x value, so that's going to be all alone on the exponential. 2 is the base, so it's going to be the base on the exponential now. Y is the power of 2. 2 to the y equal 1/16. Now you've rewritten this logarithmic form into an exponential form. And again, we want to try to get the same base. We can do that. We can get base 2 on both sides. 2 to the negative 4th, that'd be the same as 1 over 2 to the 4th, or 1 over 16. So where I see the 1/16th, I'll rewrite that with 2 to the negative 4th. I've got base 2 on both sides. I can remove the 2's and set the powers equal. And so I've got y equal negative 4. So log base 2 of 1/16th, that's equal to negative 4. Now, in the 115 class, I mentioned that you can't take log of 0 and you can't take log of a negative. That doesn't mean that you can't have a negative or 0 coming out of the calculation. Like that will happen sometimes. I'm calling this y, right? And of course, there's a difference between y and x. So just take note of that. Okay, part C. I want to find the value of log of 0.1. When there's no base, we're working with base 10. You can write the base 10 if you want or not. It doesn't matter. But just know that we have base 10. And knowing that we have base 10 in exponential form means that I'll have 10 to the y. 1/10 is my x value, so that's going to be all alone on the other side there. 1/10, that's the same as 10 to the negative 1 power. And now that I've got base 10 here on both sides, I can remove the 10's and set the powers equal so that y is equal to negative 1. Okay. Now, part D, I want to find the value of log base 8 of 1. Log base anything of 1 is always 0, but here would be the calculation for this one here. If you call that y and then rewrite that equation into exponential form, 8 to the y equal 1 is what you're solving for y. Anything with the 0 power is 1, right? So now that I've got base 8 on both sides, remove the 8's and set the powers equal, and that's, this is one way to look at why it is equal to 0. Log base anything of 1 is always 0. Okay. Problem 14 is some more with finding values of logarithms. In these problems here, we're using our properties of logarithms. I had went over the properties of logarithms, the laws of logarithms, in another video in the 115 class. Make sure that you know the laws of logarithms, okay, because you're going to be using them for calculations, where you're finding values or solving equations. Let's take a look at these ones here. So part A, I want to find the value of the ln of the square root of e. Well, the square root of e, that's the same as e to the 1/2. And I know from law 3 on this list here that powers can come out of logarithms. So that 1/2 can come in front of the logarithm. And the ln notation is shorthand notation for representing log base e. So if you have log base e of e, that is equal to 1. That's using law 5 here. Or the ln of e is 1. 1 half times 1 is 1 half, so the ln of the square root of e, that is equal to 1 half. Part B, okay, we got 5 times log base 6 of 6. So yeah, whenever the base and the input number are the same, you always get 1. That's law 5. 5 times 1 is 5. Part C, okay, whenever you're subtracting logarithms with the same base, law 2 says that you can combine that to a single logarithm where you're dividing the inner terms. So I can look at this as log base 3 of 15 over 5. 15 over 5 is 3. And log base 3 of 3 is 1, since the base and the input number are the same. Again, using law 5 there. Okay, part D, log base 6 of 12 plus log base 6 of 3. Well, law 1 on that list says that whenever you're adding logarithms with the same base, you can get that to a single logarithm by multiplying the inner terms. And so that's what I'm doing here. I'm getting a single logarithm, and I'm multiplying 12 times 3 is 36. Log base 6 of 36. Well, 36, that's the same as 6 squared. And that's how I'd want to look at this, because 2 is a power that can come in front of the logarithm using law 3 there on that list. And 2 times log base 6 of 6, well, log base 6 of 6 is 1, and 2 times 1 is 2. So the answer there is 2. Okay. The change of base formula was the last formula here on that list, and sometimes we want to change the base to a new base, and when we do that, we want to plan to go to the calculator, because, you know, on the calculator, like, I've got a log button, I've got an ln button, but I don't have like a log base 6 button or a log base 9 button or a log base 7 button, you know. So it's really if I want to change the base and turn the problem into a calculator problem. Now, in part A, I'll change the base to base e, and you're going to have 0.77 going into the natural logarithm in the numerator. The old base is going to go in the natural logarithm in the denominator. And so then we can go to the calculator here and type in ln of 0.77 divided by ln of 6. And I'm getting negative 1.46 if I go nearest 3 digits. Note that, again, sometimes we can have a negative coming out of the calculation. So log base 6 of 0.77, that is roughly negative 0.146. Okay. Part B is another change of base problem here. So the reason why we're changing the base is 85 is not a power of 9, 17 is not a power of 7. Okay. So we'll want to change the base on both of these, actually. Log base 9 of 85, if we change the base to be base e, that would be equal to ln of 85 over the ln of 9. Log base 7 of 17, if we change the base to be base e there, would be ln 17 over ln 7. Okay, so then I would go to the calculator and type this in here. It's going to be, you can type in the whole thing all at once if you want. ln of 85 divided by ln of 9, and then plus ln of 17 divided by ln of 7. Hit enter, and I'm getting 3.48 or 3.478 if I go nearest 3 digits on that. Okay, and that would be my my answer then.